Hey everybody, this is Alex Merced and welcome to another episode of Gnarly Data Waves, and we have an exciting one today. Um, Basically today we're going to be talking about how NetApp is redefining the customer experience with product analytics. It's going to be an exciting story and you're going to want to be there for the whole thing because it's also so good. But before we do that, obligatory announcements that I need to make, and one of those announcements is, of course, the best way to understand what the Dremio Lakehouse platform can offer you is to get hands-on with it. And there are many ways to get started, and you can get started for free, whether it is through a self-managed deployment, okay, with many options to deploy through Docker, Azure, AWS, Google Platform, Kubernetes, and more, or whether you're using a cloud managed instance of Dremio using Dremiocloud. And then again, even before you create your Dremio Cloud account, you can use our test drive feature to get hands-on to kind of see what the experience would be like. But to try any of these things, again, for free, head over to dremio.com/get started so that way you can kind of get started on your Dremio journey today and seeing the value that it can bring. Also, just a reminder, me and Dipankar Mazumdar will be at Data Day, Texas in January to do an Apache Iceberg Ask Me Anything over there at Data Day, Texas, in basically leading up to the release of the book that we've been writing here at Dremio, the Apache Iceberg, the Definitive Guide, which will be published by O'Reilly. Exciting times. Again, you can get yourself an early access copy by scanning that QR code right there. So right now, I think the current version of the early release is like 180 pages plus. So lots of great content on Apache Iceberg. We're getting close to wrapping it up. It's pretty exciting. But of course, also make sure to visit Dremio at any of the following events, whether it's Coalesce by DBT, which I think is this coming week, Data Lakehouse meetup in London we're going to be having over there on October 17th. If you're going to be at AWS reInvent, visit us, our table there. If you're at Microsoft Azure and AI conference over there in Orlando, December 5th and 7th, my neighborhood of the world, that you can visit the Dremio table, get some swag, and ask some questions. Where we always love to hear about sort of your experiences with your current infrastructure, and that's to kind of get to know you. So come pay us a visit. And also make sure to visit the Dremio blog at dremio.com/blog to find all sorts of articles on all sorts of great topics on the Data Lakehouse and Data Lakehouse adjacent technologies. So make sure to check that out. And of course, here at Gnarly Data Waves, which you can subscribe to on iTunes and Spotify, so that we can listen to previous episodes if you want. We have other great episodes coming up in the coming weeks, such as building a data science platform on Apache Iceberg and Nessie, and how to build an Iceberg data lakehouse with Fivetran and Dremio. So keep coming in every Tuesday at the same bad time, same bad place. But with no further ado, time for our feature presentation, which is an exciting one about how NetApp is redefining the customer experience with product analytics. Joining us today will be Aaron Sims, Technical Director over there at NetApp, and Tony Churong, Senior Product Marketing Manager here at Dremio. But with no further ado, Aaron, Tony, the stage is yours.
Thank you, Alex. Hey, everyone. Good day. Thank you for joining us today. My name is Tony. I lead solutions marketing here at Dremio, and today I have a special guest, Aaron Sims. If you're joining us here today, you're probably interested in how they are redefining their customer experience with product analytics. And Aaron's going to share a little bit more about how they started from Cloudera on-prem and have modernized to Dremio's data lakehouse. So with that being said, Aaron, I'll let you go ahead and kick off the show and do your thing.
All right, great. Thank you for that. Again, Aaron Sims, I'm the technical director at NetApp. I've been in the industry, either through systems engineering or more recently with the data processing platform that we have inside of activeiq. I'm the chief architect for NetApp activeiq. We take in product telemetry and have an analytics platform, and Dremio is a big piece of that, and I'll talk to you about that. In addition to our processing platform, we have a number of different databases, we have a couple different API platforms, as well as several front ends as well. So a little bit about NetApp. We've been around for about 30 plus years. Initially started out as a NAS company, and eventually became a NAS and SAN company, and we've since branched out into what we call the hybrid multi-cloud. So you can have your products in the cloud. You can use our products in the cloud. You can use them on-prem. Have them all work together seamlessly, and move your data where you need it, and have it close to what the area that you're supposed to have it in. We're definitely a leader in the all-flash storage array business, and we, as I mentioned before, our OS is actually available natively in Amazon and Azure and Google GCP as well. So a little bit about activeiq. activeiq is as I mentioned, it's our predictive platform where we can do a lot of machine learning and AI on the telemetry. We have hundreds of thousands of products in the field. Some of them are based on our flagship product called Data on Tap. We also have a number of other products. Some direct attach types of products like E-Series. We also have object storage in our storage grid, and we also have a number of, as I mentioned before, a number of these things also you can run in the cloud. The telemetry is all based on what we call auto support, and as the name implies, auto support was originally intended for to use that telemetry for support purposes. When customers would call in, we'd have at least some idea of what's going on inside their environment. We do things with that telemetry like automatic case creation, but we also do a lot of analytics on that data. So out of the 10 trillion data points a month we get, we process a lot of the data, and about a lot of that data winds up in our data lake for other purposes, such as looking for sales potentials, cross-sell, upsell types of activities. Our product teams use the analytics to understand how our customers are using the products, and then, as I mentioned before, we still have a lot of work that we do around the support side of the application. So a lot of this is internally facing that I talked about, but we also have a lot of externally facing pieces to this as well. We have the activeiq Digital Advisor, which is our customer facing website. We have a mobile app, and we also have customer facing APIs as well. So when we, as I mentioned before, when we first started bringing this telemetry data in, we just use it for a support use case, but eventually we started finding all these other use cases, and what we wound up building was a Hadoop infrastructure. Mainly started with MapReduce. This was probably close to 10 years ago now that we started building this, and we kind of started small, and it just kind of kept growing. And one of the challenges, while this was great, we were actually able to work with a much larger data set than we were used to with before. Everything was flat files and some ETLs that would transform some of this and put it into Oracle. Now we're able to work on a much larger data set than we were before. So the cool thing was, hey, we could do this, but the downside was it was really slow. And as our Hadoop infrastructure kept growing, we found we had a lot of other challenges as well. So one of the biggest ones was that the amount of storage we needed was the thing that was growing more than the amount of compute that we needed. And the downside of the architecture we had was that the compute was directly attached to the storage. And so if I needed more storage, I couldn't add more storage to the servers we had. So we wound up having to grow horizontally. And so every time I would need to grow storage, I would wind up adding more compute that I really didn't need. And that, not only did I have to pay for those servers, but the Cloudera licensing also increased along kind of linearly with that. I mentioned before that hey, we're able to do this, but performance was not very good, right? So our average query was somewhere in the range of about 45 minutes to do most of our queries. On the operational front, Hadoop and Hive and those kinds of things have some the resource controls are not very, they're kind of coarse grained. And it was, we found that, some people would misconfigure Spark jobs and could easily, consume all the resources in the cluster and starve out other tasks, including things like Hive queries. And that was actually, Hive queries were probably the bulk of the what people were doing within our Hadoop cluster. Infrastructure upgrades were also a painful process for us as well from an operational perspective. In fact, upgrading, CDH or CDP was really just a nightmare for us. And so we wound up not doing it very often. And, just because it was such a pain. And, so we tended to put those off as long as possible. And this usually made us wind up at the tail end of their support matrix as well. So On the storage side, using HDFS, large block sizes, replication factors, tended to make that very inefficient for us. And we initially started out with a replication factor of 3, thinking, hey, this is going to be great. Our data is very safe with this, and it was fine. But that had a very heavy cost that went with it. So eventually we got more comfortable with it, and we dropped, as storage needs increased, one of the ways that we tried to delay buying more storage was to start to drop our replication factor down to 2. And again, that was fine, never really had any issues with that. But again, still it's a full copy of the data. And when from being a data storage company, we tend to look at storage efficiency with it, being an important thing for us. So, and then finally on the data governance side, one of the things that initially our data lake was very open. It wasn't really a big deal back then, but as more controls started coming into place with respect to CII or company identifiable information, personally identifiable information, those kinds of things, we started needing to put these controls in place that would restrict that access. And so but Hadoop was not a good platform. We'd have to go buy some more software in order to lay those appropriate controls into place. So, kind of an idea of what our infrastructure looked like before we put Dremio in. The product telemetry would come in from all our products, around the clock. To get the data into our Hadoop environment, we had some Kafka streaming, some Apache Flume, and a couple other things that would deposit the data into our data lake. And then, as I mentioned before, we wound up with about 30. So we had the concept of a mini cluster. So we have one storage array and 4 servers directly attached to it. So we wound up with about 33 of these things at one point. That totaled out to be about 4,000 cores and about 7 petabytes of disk on the floor. So, when we, in fact, about the time that we, had a kind of a scheduled purchase being planned and made, it's about the time that we started really kind of, looking at, is this really the best way for us to do this? So with that, we started looking at alternatives. We definitely wanted to decouple our compute and storage, right? The compute costs were, out of whack with what we needed to do. So, in order to make this more efficient, we decided to, that this was going to be the biggest factor in our growth, or in our changeover to this. Since we have just recently purchased some new servers, because we always kind of had a pipeline of servers, that would be older, and we would rotate them out. We were always kind of buying new to refresh, and then sometimes new to expand. So we had an existing compute investment that was still had several years of support left in them. We wanted to make sure, we certainly wanted to prefer to keep that, and so to minimize the cost here. And along those same lines, the data pipelines that we had, we really didn't want to have to change a lot of that. And so some of the other vendors that we considered along the way would have required a very, very drastic change to how we process our data. And that was, going to add to the time and the expense of all of this. The other big factor for us was, that 45-minute query time. We really needed to get that to come down. And so that was going to be another big factor for us. As I mentioned before, on the data management side, we really just needed those fine-grained controls that would allow us to give people access to the data they're supposed to have access to and whatnot. And then also at the storage layer, how to manage that data. And I'll talk a little bit about what features we're using in the storage layer as well. As I mentioned before, better resource management, be able to give carve out chunks of compute for groups that in a more dedicated manner, make sure that people can't starve other people out, kind of thing. So that was another big thing. And we also started to have the requirements around from a disaster recovery standpoint. And so with that, we as I mentioned before, we wound up looking at probably about 3 or 4 different vendors. Dremio made the short list from the standpoint of the strength of the portfolio, the open standards around the Lakehouse query engine, the semantic layer. I looked at that and said, even though this is we're evaluating this specifically for replacement of our Hadoop infrastructure, the semantic layer actually had some very interesting secondary use cases that I was looking at to say, hey, this might solve some other problems for me down the road, but we're going to initially focus on replacing Hive, and then the thing that really just blew us out of the water was performance. And I'll talk a little bit about the results of that, but we kind of when we first did our POC with this, put some data in it, we're all kind of, when we started running some of these initial queries, we're kind of looking at each other going, how did this get so much faster? And especially with the less compute that we had in our POC environment. So this is what our architecture looked like afterwards. So even though the telemetry data is still coming in here, we're feeding the data directly into S3. So as the data gets processed, we're store that data into Parquet format. As I mentioned before, one of our products is StorageGrid. So StorageGrid is our object data platform. So it's S3 compliant, which is great because Dremio obviously supports that. So we, as the telemetry data comes in, we write directly to Parquet files or objects in our StorageGrid. So there's dedicated buckets for each of the tenants and that kind of thing. And so we have our product telemetry in groups of different tables. We have about 8,900 tables. It's bordering on 9,000 now. And so all of this, the Dremio environment was actually put on top of Kubernetes. So our old Hadoop environment was bare metal. Bare metal was really kind of painful for us to manage, especially when it came to things like patching and that kind of stuff. So we decided that we really wanted to containerize all of this. So all of our Dremio environment, including all these supporting services like Prometheus, there's a Postgres database in there as well. All the things that kind of do all that's containerized, all that runs in our Dremio Kubernetes cluster. So we wound up buying about 16 executor licenses for this, and so these multiple of those executors run on different nodes underneath the cover. So and I'll talk a little bit about the savings from a compute perspective in just a little bit. But the other aspect is that the amount of disk that I needed on the floor also shrank quite a bit, and I'll talk a little bit about the benefits of the using StorageGrid as the back end. So a lot of our migration was really about getting this Dremio put into our existing data flows. So when we initially built this, we basically put Dremio after the data flowed into Hive. So we're basically every day copying data out of Hive into Dremio, since the formats are compatible with each other. And so as we're doing this gives us data that we can actually bring to our users and say, all right, let's talk to each group of users that we have, look at the queries that they're doing, prepare basically for the migration. So how are we going to migrate their existing queries into the Dremio environment? And as we're doing that prep for the migration, everything, we're also working on bifurcating the data from our existing data flows. Instead of writing to Hive and then to Dremio, we want to write to Dremio directly as well. So we're getting all that stabilized. And basically at a certain point we said, all right, this is we felt we're production ready. And we had a lot of user groups that were we'd already figured out their query transformations and everything. So at a certain point we said, all right, we're production ready, and we started migrating users over to that. And basically, it was kind of scheduled. So it said, hey, this group do it on the, since you're ready, this is your week to do it. And basically we're able to migrate 130 or so users in about 2 months. And that honestly, when we set out to do all this, we didn't think the migration was going to go that smooth. And we were actually, that was the thing that we were most scared about. So, that actually the migration itself turned into be, and much faster than we ever anticipated it being. Once we found how easy this was to cut over. So, we did want to talk a little bit about StorageGrid. So as I mentioned, StorageGrid is the NetApp object product, and StorageGrid has some really cool data management features. So information lifecycle management is we have a series of ILM policies that we can apply to the data that sits on our storage. So one of the, as I mentioned before, with HDFS, you're doing direct replication. So if I write a block out, it's written twice on the two different nodes. With StorageGrid, it works kind of the same way. You can do exactly that. You can write out a file and say, all right, or write out an object, and that object will be put onto as many nodes as you say initially. So if your replication factor is 3, you write out your object, and it's going to be duplicated or triplicated across nodes within that cluster. So one of the cool things about our ILM policy is that we have something called erasure coding, and this actually takes an object. If you think about like a RAID array where you have redundant disks and you calculate parity in order to protect that data, erasure coding is a kind of the same kind of thing. So in the StorageGrid that we built was actually 7 nodes, and we set up what's called a 4+2 erasure coding policy. So when a object winds up being written to the grid or the bucket, I should say, that object gets broken up into 4 chunks. So let's just say it's 40 gigabytes in size. It'll be broken up into 4 10-gigabyte chunks, and then you will have a parity calculated, and 2 more parity chunks are written to other nodes. So with this, instead of a replication factor of 2, my overhead is 100%. With this, my overhead is only 50%. So I get better storage efficiency for this. The other aspect of this is, since my object is chunked up into pieces, when I go and ask for that object from the grid, it actually serves all that data in parallel and hands it back to me. So I actually get better performance out of that as well. The ILM policy also makes it really easy for us to do disaster recovery, and I'll touch on that in just a little bit. And then finally, with the ILM policy, I can also set a policy where the older data. So let's say I only want to keep 2 years of data in my data lake. I can tell it, say, when this object reaches 2 years, it automatically removes that from the storage. So I don't have to write external scripts to go manage all this data. The policy takes care of all that for me. As I mentioned, we do have a disaster recovery setup going on with this. So in my primary data center, I have 7 nodes within the site. And with StorageGrid, you can create multiple sites within your grid. So if I write objects out to the site here in my primary data center, the ILM policy also allows me to replicate that data and those objects into the site in my secondary data center. And so, basically, I'm always up to date. As I write data here, it automatically gets replicated there, and I'm basically always in sync. So, with maybe just a few minutes of lag, perhaps. So what our disaster recovery plan is, since all of my Dremio infrastructure is running on Kubernetes, it's all set up with Helm charts and everything like that. I have my sub-prod infrastructure that sits in the secondary data center. And so our goal here is that if we declare a disaster, all of my data is already there. It's all accessible through the same addresses effectively, since the load balancers also share the same name. So all I really have to do is just run my Helm charts, spin this up in my Kubernetes cluster in the secondary site with the production config, and I'm done. So the process of doing this is really, really straightforward. In fact, this is so much easier than the process I have to do for all of the rest of my infrastructure. This is by far and away the easiest DR process I have within our environment. So, what were the outcomes for us, right? So I mentioned early on that we had 130 plus servers, and we had 4,000 cores. After I cut all this down, I wound up with more than a 60% reduction in compute. And as I mentioned before, we were kind of shocked that I can take away that many cores out of the environment, and wind up with what turns out to be about 10 to 20 times the performance. So that 45 minutes, for the average query time, our largest queries average today about 2.5 minutes. So big, and a lot of our smaller queries actually get measured in seconds. Our overall TCO savings, we saved about 30% overall. So obviously, less compute, less data center space, less storage. And this will actually play out well for us. We were able to take some of that old compute and dedicate it to other purposes. So, we didn't have to go buy other stuff. And I mentioned earlier that we migrated about 130 users. Well, we've actually gotten a lot more users since then, because this becomes a much easier platform to use. The data catalog is there. It's easy to discover the data. It's easy to go query it. We've got a web interface that makes it really straightforward. As soon as they want to get serious about it, they can start using some things like Aeroflight or whatever. So, this was a huge bonus for us. So what's interesting was, as I mentioned, we were really interested in doing this as a as a complete replacement for our Hive infrastructure. Now, what turned into we started thinking about other use cases for Dremio, right? So there's a lot more capabilities there than we're actually using. One of the interesting things that we actually wound up doing, we did a POC around this, was in our DataStax environment, we actually keep, or I should say, we used to keep 7 years of data in our DataStax environment. And this has is a pretty big environment. There's like 24 servers, 27 servers, something along those lines. And so we decided that that was just too big, and nobody really ever goes and accesses that older data. So we decided to tier the data. So that data that we shrunk that DataStax cluster down, keeping only 2 years of data, calling that hot, even though that I think we could have been more aggressive with that. And then basically years 2 through 7 wound up going into Dremio, and we changed our APIs such that when you pass in your date range or whatever, it knows how to go either read from DataStax directly or read from Dremio. The cool thing was that our DataStax queries got to be a lot faster in shrinking our data set like that. Even with fewer servers, we actually almost cut our server count in half with our DataStax cluster. And the queries for the older data into Dremio actually were reasonably performant, compared to what they used to be in DataStax. So all in all, this was a big win for us. So we actually sped some things up. Started treating using Dremio as a secondary use case. We're actually doing a POC on this right now, which is to as I mentioned before, we have a lot of ETLs. We carve up data, join data, whatever, make copies of it for specific use cases. That has challenges from a data integrity standpoint. So what we're experimenting with right now is, can we use Dremio to effectively be the query access layer for all of our databases, and not make so many copies of it, but to basically do our ETLs on the fly as we need to. And so that's the current experiment we're doing. But that's we're actively trying to find other ways to make our lives simpler, and Dremio's being a big part of that. And with that, I will say thank you.
All righty. Thank you, Aaron. And folks, if you guys have any questions, please feel free to drop them in the chat below, and then we'll take them during the Q&A session.
Yep. So we got, go for it. Sorry.
Yeah. So I think I have one good question we could probably start with. So there seems to be a lot of folks that are, seemingly breaking into the data lakehouse paradigm shift. So a question for you, Aaron, like, what is one thing that you could demystify for those that are looking to modernize to the data lakehouse on a journey similar to you?
Yeah. So, one of the things that I as we started looking into this was, hey, this is going to be a really big effort. And, once we got through it, or even got halfway into it, we're kind of going, this is a lot easier than we thought it was. So, any trepidation that we had before, melted pretty quickly once we started playing with the product. And so, I really wouldn't change anything except for that. I wish we'd started earlier on this.
Awesome. Yeah, thank you. I think that's like a really good thing to call out, is just starting on the journey.
Yep.
Let's see, we have any other questions?
I have a question. Like you mentioned how sort of like you had a huge increase in sort of the number of users that started using the platform once it was created. Like sort of like how did the interest kind of generate? Was it like sort of like a word of mouth, or was there some sort of catalyst for that?
I think largely it was word of mouth, and we never really did a lot of heavy marketing of this internally or anything like that. This was a lot of getting our users to migrate over. I think they started having better experiences with it. The overhead in terms of the knowledge ramp up that you have to do in order to start to access it was considerably lower. That the bar to get into our old Hadoop environment was actually pretty big. In fact, I remember the first time I ever got access to it. I was actually in a different org, and try to get to it. I was like, man, this is a pain. And with this, that bar is a lot lower. So I think naturally, other people that hadn't already climbed that hill before, are kind of looking around. It's like, well, this is a lot easier now. And when somebody else asks them to say, hey, you know what, I got this question. How can I go answer it? They go, all right, go here and do this. And the demonstration of how to get that is a much easier prospect for them to, so the data, in my mind, the data is a lot more accessible, and therefore people, jump on and try it out and go, oh, this is easy. And so they keep using it.
Awesome. And then one other question is, like you were talking about earlier about sort of like the changing, sort of like having to put more controls in, because basically originally everything was kind of open, and then requirements for like CII, PII, and whatnot. How has that part of the experience been since introducing Dremio on that end?
So we one of the things that we had to do was to segregate data before into different pools. We also had to encrypt a lot of fields, those things would land encrypted in our data lake. We are in the process of kind of switching over to actually start to use some of those controls better. And not only that, but as I mentioned, the whole thing I was talking about earlier, where can we do ETLs on the fly with all of this? We definitely intend to hook that into our back systems. So I'd say our journey on that front's not quite complete yet, but we're definitely heading that way.
That's awesome. Again, if anyone has any questions, there's a Q&A box and a chat box. Any question in either will. Here we go. Accessibility, ease of query authoring, speed of execution, less time waiting, more time being, data-driven. I think that was.
Yeah, so actually one of the less time waiting is actually an interesting part of this for us. So, as I mentioned before, average query time being about 45 minutes. Just query development was a painful kind of thing, right? So if you're dedicated to this for, all day, best case scenario, you're going to get, 8 or 10 queries done a day. Sometimes it's very iterative thing, or you'll get, into your query and find that, something broke or whatever and so having, a shorter, or I should say better performance allowed, people who are developing queries to iterate much more quickly. And so I think that's, part of the boon in this is that we're allowing users to be more productive when they use this, even from a development standpoint.
That's awesome. I always love hearing that, because I do find, like, I know when I'm on the Dremio panel, like, just like oftentimes query authoring is like a very pleasant experience to be able to just like look up a function if I need to or whatnot. So
yeah, and actually awesome. I'll say one, at least from my point of view and me using Dremio, having just the ability to do a query preview is a huge thing. It makes it so much easier for me to not return all the whole data set, but I can get a short preview, and those are even faster. So that's been another big part of this for us, at least for me, that in my experience of using this as well.
Nice. And there was a quick question about whether the video will be posted online. So just a quick answer to that. Basically, this always gets posted within 24 hours on YouTube. So by tomorrow morning. And then we'll also be posted on iTunes and Spotify within 48 hours.
Aaron, I have a question for you regarding self-service. So that's like a lot of the conversations that we are hearing come up is how do we get data faster to our users and enable them to access it, in a way that's like that, so that they don't have to go to the central IT team. What has your experience been like using Dremio, enabling that for the end users? Like, are they filing less tickets with central IT, or are they able to go in and explore? Can you talk about that process?
Yeah. So the access issues, query issues, that kind of stuff. By and large, that's mostly gone away. What we're generally left with is, hey, this data didn't necessarily arrive. But that's outside the control of this. That's down on my data pipeline, and issues that I have around that. Most of the time now it's a ticket to get initial access and understand what the role is, and then giving them access. But once they're in it, very rarely do we get questions. Certainly not the type that raise tickets, and that kind of thing. So overall, I mean, once the user gets access, and we've got some tutorials that they can go through to kind of get their feet wet with it and everything, they're off to the races. So overall, we don't get a lot of our I should say our incident count is a lot less than it used to be.
Got it. Yeah, that's usually like one of the intangible benefits of making self-service BI easier, because unlocks the productivity on central IT and on the business side. So I'm glad that worked out with you guys.
Then one final question for me. You were talking about how, in your next effort is the idea is to kind of replace like a lot of these pipelines and using sort of like the ETL on the fly with Dremio based on the query. Basically, when you get there, so what are the kind of the pain points that currently exist in sort of having all these pipelines that you're hoping to sort of like alleviate once that's implemented?
So, as I mentioned before, we're making copies of data or slices of data that get copied into a use case specific database or collection or table or whatever. Keeping those all in sync. So if something changes, it may take hours for that to percolate through our pipelines. So when that happens, we often are chasing like why is this data different here than it is over there? Was the pipeline broken? Was it the fact that, hey, it just hasn't worked its way through this one branch or whatever? I think the goal with that concept is that I now have, instead of having lots of copies of my data, I now have single source of truth for any one type of data, and so I don't have to worry about what's the lineage of the services that got data into this one destination or whatever, because often it goes through probably 5 or 6 different services before it even lands in its final destination today. So my pipeline shortened considerably. I have obviously a lot less services to go and manage. Governance becomes easy because and not only that, but governance and RBAC become a lot easier for me because I'm just creating virtual data sets to do those joins for me on the fly, and I can put my controls there. Governance around who has access to what and that kind of thing becomes a lot easier. I don't have to deal with RBAC necessarily at each individual database. I can now do it all in one spot. So
that's awesome.
Yeah, it's a theory. We're going to see how well functionally if it's going to do what we want, and then we'll scale it up and see if it performs too.
Awesome. Okay, I really look forward to hearing how that goes. Let's see if there's any other questions. I think that is all the questions we have for today. But I want to say, Aaron, Tony, thank you so much for being on the show today. This has been absolutely fascinating. And definitely, there's definitely going to be all sorts of thoughts that are going to be percolating in my mind for the days to come. And well, keeping me up at night thinking like that's pretty cool. But yeah, no, we definitely look forward to maybe following up as we see where some of these efforts go and how they end up.
Great.
And yeah, just want to say thank you to both of you.
All right. Thank
Awesome.
you. Appreciate
Thank you,
being here.
everyone. Thank you, Aaron, for sharing your journey.